Welcome to the beginning of this series where I show you guys an introduction to Godot while we make a 3D game. Okay, this is a different type of video from my usual videos, right? They're usually tutorials, but I decided why not make a guide, a introduction to Godot 4. And this is going to be in 3D, so if you want a 2D guide, I wouldn't really suggest this video for you, but if you're looking for 3D, you're in the right spot. Okay, so you can see I created a new project right here. There's nothing in here. Okay, so during the series, I'll be showing you guys how to make a maze game where it randomly generates a random maze and you as a player have to escape it. Now, depending on what I think of in the future, we could go as deep into rendering things, particles, effects. We could really make the game look good, but for the beginning part of the series, it's mainly going to be focused on the general concepts of scripting and not so much of the front end of the game. Okay, so let's just get straight into it. So in this video, you could probably see in the title, if I made it the title, we're just going to be setting up the project and creating a player. So when you first open up a project, right, you'll notice on the bottom left there's a file system, and this file system, it's like your file explorer for your game, if you have Windows, of course. So we want to keep our project organized, and this will help us in the long run. So you could right click on res, whatever this is, right, and add a new folder. So we're going to call this assets, press OK, then we're going to right click, press new folder, and we're going to call this player. Then we're going to add another folder, and we'll call this one world. Okay, so left click on assets, press right click, new folder, and this time we're going to create a folder called world and then player. Okay, so going into this tutorial, I just want to let you guys know I'm expecting you to have some programming experience, but if you don't, I'm sure you'll be able to catch on quickly. It's nothing in this video, at least, will be that hard to understand, but anyways, the reason I created assets folder is so if we have any assets, like so if we have a player model we want to add to this game, we would add it to the player folder, which is under the assets folder, and not the player folder, which is under the general file. And that just helps keep everything nice and tidy. Okay, so once we have that down, I just want to click on project right here and project settings. So this is where you can see all your project settings, of course. It comes with a few things. You could also click advanced settings. You'll get a bunch of more options, but we won't go into anything details like that. So if you go to window, display window, you can change all these settings to what you'd like, but at the moment I'm not going to change anything except actually never mind, everything should be good at the moment. We'll have to change it some things later, but to continue on, let's go over what a scene is. So I have no experience of what Unity or Unreal Engine is, or like the process of which you would create games in that. But in Godot, we use scenes, and scenes are basically almost think of it as a file like this, right? This player file will help us make the assets folder. So it's kind of like a building block, and these scenes they're created with, imagine, bricks. These bricks will help create the scene. So they're called nodes. As you can see, create root node. So the root node is basically the parent of all the nodes that will be a child of it. So to begin with, we're going to press other node. We're going to go type in character body. And just to go over a few things first. So Node 2D, anything with a 2D at the end is obviously for 2D games. Control are basically GUI nodes. Those will probably be mentioned in another video, but what we're going to be working with right now are Node 3Ds. In this, we'll have, let me find it, if I can find it. Okay, yeah, so it's in collision object 3D. You can see physics body 3D. You can notice right here that there's 4 bodies, right? And these are really a main part in building games in Godot. They're really useful nodes here. And static bodies, they're for objects that don't move. Character bodies are for bodies that are used for building players or enemies. Physical bone, that's not really, can't really use that. But rigid body 3Ds are have like ragdoll physics, and they're really different compared to character body 3Ds. So if you were to make a player, you'd either go using 2 of these options, but most likely you would want to use the character body 3D unless you have like a physics-based game. Okay, so we add a character body in, and you can see this little error or a warning. So if you click on it, it says the node has no shape, so it can't collide or interact with other objects. Alright, we're gonna ignore that for like a moment, and we're gonna type in mesh instance 3D. Okay, so what did that do? It did nothing. So a mesh are basically will help us visualize things in the game. So if we wanted a wall, we're gonna have to use a mesh. If we wanted to see what the player actually looks like, we're going to add a mesh. So that's what we're gonna do. So adding a mesh instance isn't enough. You can see on the right hand side there's a property we can fill out. So you can click on this empty button and you get a ton of options, and it doesn't matter that much of what shape you want, but I definitely recommend using the capsule mesh, just because in the future you'll understand more why I'm recommending this, but it just helps with collisions. So we're going to choose capsule mesh, and if you want to change the height and radius of this, you can just change these properties. Alright, so we finished creating our mesh of the player. and that only gives us a visual representation of the player, and that's only helpful for the person playing the video game. So now we must add a collision shape, which this warning tells us to do. And a collision shape is the game's representation of what the player is. So let's actually press cancel, and if you click on the mesh node, right, at the top you'll see this little mesh button. Click on that and you'll be prompted with a bunch of options. So if you ever want to create a static body off of a mesh instance, you'd click this option, and everything else it uses, well, including the static body option, it uses this mesh which you created to produce any of these options. So a trimish, as you can see, if you hover over it, it gives you a tooltip, and the trimish collision sibling is the most accurate but slowest option for collision detection, and we don't really want that. In fact, we don't really want any of these because they're convex collisions. So instead, we're going to add a collision shape, and we're going to click the shape over here, and we're going to press capsule shape, and that's the exact shape our player is. So since our player is just a capsule, right, the best option is just going through a normal collision shape and adding a shape over here, like an inbuilt shape. But pretend you actually have like a human model. That's when you would go to mesh and click one of these options, but I highly recommend not doing that. Basically, like, if you're gonna have animations on a player, so if you have a collision shape, as far as I know, you cannot animate a collision shape, so this wouldn't really work of benefit. So I'd recommend almost always using one of these inbuilt shapes, but obviously if you really have to, you can click any of these options. And a collision shape doesn't have to exactly match your mesh. So if I had like an entire person, right, I just have to get the rough shape of the player. Okay, so didn't mean to do that. At the top left, you may notice it says unsaved. So let's just go ahead and save that right now. So we're going to press Control S, and we're going to double click the player folder, and at the bottom we're going to rename this to player and press save. So just as a habit, you should always press Control save, and it will automatically save your entire scene. And that's just good, that's a good habit to do unless you want to lose your work. Okay, so we have that down. We have the collision shape. This will allow our player to actually hit walls and not fall through floors. Without this collision shape, the game won't recognize where the player is. And the physics bodies, which again, they are part of a node 3D and collision object, physics body, all of these options, they will not recognize where the player is without the collision shape. Okay, so that's done, but we can't move, we can't do anything. It's basically all useless at the moment. So let's set up our player and then we'll add a script, and that's really it. That's the timeline of the video. So a quick keystroke is Control A, and that pops up the node menu. Like all these keystrokes, they just help to basically give you a faster working experience or a better workflow. Okay, so we can search for a normal node 3D. Might be wondering why we want this, but you could use node 3Ds as essentially files. They're there to almost be a way to organize your projects, because obviously they are completely useless. If you look at all the other nodes we have access to, they all have a useful feature to them. Like a node 3D doesn't really have anything, but if you click on collision polygon, it gives you this entire thing. Okay, so we're gonna rename this to neck, and this, we're gonna move this node 3D to where our neck should be, and I'm gonna press Control Save to save it. And let's go over what transform is. So if you've ever used like Blender or any other game engine, you should know what transform is, but just in case you haven't, it's basically moving in the object's position in the 3D space, as you can see. So if I wanted to transform this mesh, I can just move these little arrows, right? And I could do that. I could use the arrows, or if I want an exact value, I can scroll down, click on the transform section, which is under node 3D. It's going to be that for every single node 3D, or every node that's under the node 3D section when you press Control A. So any of these nodes. Okay, so pretend I want to move this node 10 meters on the x-axis. I can do that, and it's right there. And I can press Control Z to undo. And another quick tip, if you're moving these arrows and you decide, actually I don't really want to move this, then you can press right click while moving them, and it'll automatically go back to its original position. Anyways, we're gonna move this neck, this node 3D, up the y-axis. So as you can see, the y-axis is the green line, which is vertical, unlike these two axes. The blue one is the z-axis, and the red one is the x-axis. Z is always the direction, is basically forward in Godot. Anyways, you don't have to have like a precise value for where the neck has to be. Just anywhere that's a little up. But you do not want to move, you do not want to transform it on the X or Z axis. Okay, so we have that down. Now we're going to press Control A again. We're going to add a camera, because we'd like to see. And you notice the camera is pointing off that direction, and that's another way to figure out which way is forward. Okay, so that's our camera, and the camera is a child of the neck. And the next parent is the character body 3D. And we're also going to double click on this, change this name to player. Control S to save. And another tip, if you're looking for a certain property, there's a search button over here. It's quite useful if a node like a mesh has a lot of properties, right? Okay, anyways. There's one more thing that I'd like to go over before we add the script. And these are collision layers. So if you press project settings, go to project settings, which is project settings, and then you scroll down to layer names. Oops, I didn't mean to do that. And then click 3D physics, right? You're prompted with a bunch of layers. So just type in these words and I'll explain what they do in a second. Okay, so essentially, right, these collision shapes, they can be placed on different layers. So if I wanted an object that would not interfere with players, then I would basically configure its layers and masks, which I'll go over in a second, so it won't interfere with players. So if you go over to the character body, and the physics bodies will have the options to change the collisions, not the collision shape. So you go to collision and you see the layers. So the layer is what the physics body is currently identified as. So our player should be on the player layer, and it is not part of the world. So we're gonna uncheck number 1. And the mask, it's basically what the collision shape or physics body is listening for. So if I was only listening for 1 or 3, right? I actually have no clue why I added an enemies layer. I'm just gonna delete that. That's my fault. Okay, so if I was only listening to mask 2 or the physics layer 2, right? I would fall through everything and I could go through everything that is on layer 1. However, I cannot do the same if they're on layer 2. So if I uncheck this and click 1, that means I'm prohibited to pass through any collision shape or physics body that's on the layer 1. Okay, so we have that done. We're gonna add a script now. So you can see this little script looking button, and you're gonna click on the player node, which is the root node, and you click that button. You could change the script name if you really feel like it, but it should be fine. And then you're gonna see template, right? A new feature of Godot 4 is they actually have some templates. By like some, I mean 1, but it's useful. So you're gonna click on this option, and this, oh actually before that, make sure your path is within the player file that we created. It should be by default, but just in case. Okay, so I press create, and you'll notice that I have a bunch of code that just spawned in, right? And just to show you an example, this is what it would look like if I did not have a template. So it's definitely useful. Anyways, I'm just gonna delete that. Okay, so we're in the player script. And I'm just gonna paste in this code and we can go over it in just a second. Okay, so I quickly just pasted in all the code so I could explain while you copy it down. Okay, so at the very top, you notice extends character body 3D. If you add a script onto any node 3D, or any node, sorry, not even node 3D, this will pop up extends and the node, right? Because this player is a character body 3D. And you must have this matching to whatever node the script is on. Otherwise, the inbuilt functions will not work. And I'll go over what everything else means. So, essentially, in Godot 4, to create variables, which are these, right? Normal variables. Sorry, that was something else. Okay, so these are normal variables, and you can create these variables by doing var for short for variable, of course, and then what you want to call the variable, and let's call this test, right? And that's really all I have to do to create a variable. But pretend I want to create a default value. So I can do this by typing a equals button and whatever I want it to be defined as. So I can do 1, 2, 3. I can do hello. I can do I could do a lot of things, like I can do a decimal, which is a float, all of those good things. And you may be wondering, what are these colons? So basically, you can change a variable whenever you'd like in a script, as you can tell. So basically, what these colons do is it makes the variable defined to this type of, I forgot the actual word. Okay, so I meant to say data types. So a data type, usually there's a couple options. They could be a Boolean, right? As you can see, if I type that in, it pops up. A Boolean is either false or true. And another data type is int, which is integer, right? As you can see, 1 and 0, 75, they're all ints. And that's any number. However, it's not a decimal. And like, the variable cannot have a decimal and be called an int. This is called a float. I have no clue why it's called a float, but it is. And the other data types, pretty sure they're data type, but we won't be going into them in detail this video. But there's arrays, which are started by brackets and dictionaries. Sorry, I blanked out. And dictionaries, they're a little complicated if you just started programming, so I'm not going to go over them. But okay, so as I was saying, the colons, they predefine these variables according to the data type that they're assigned to. So if this variable didn't have anything assigned to it automatically that you set beforehand, you could simply do int, right? And then I would know that this variable is always an integer. It probably doesn't seem useful right now, but an example would be if this variable is defined as an integer and I wanted to add two numbers, or I wanted to what's a good example? Okay, I have no clue exactly, but if there was an inbuilt method within a variable type, then that's where it'd come in use. And at the moment, you probably have no idea what I'm talking about, but I'm telling you, it's a really good habit to learn. I didn't do it when I first started learning Godot 4, or Godot, I don't know why I keep on saying Godot 4, but it's definitely a useful tip, and it really helps with the neatness of your project. And you might be wondering, what's so special about having neat projects? Like, I've brought it up like several times right now. So, when you develop games, right? I'm talking about games specifically because I have no clue about anything else. But essentially, you have to go back through your code over and over again until you get it like perfect, right? Obviously, that takes time, and you're not going to notice errors straight away. So, like developing code and stuff, you need to be able to like analyze what's happening. And that's where the neatness plays in. So it really just makes everything 100 times easier. Okay, so obviously I don't need that. And again, just to clarify, the colon will make sure that this variable is always an integer because it's already set as an integer. It basically locks that in, and it will make sure this y speed is always equal to a float, or its default value is a float. Okay, now you might be seeing these variables confused why they're set. Whatever this is, right? So this is another syntax you need for getting a variable of a node. Of course, these nodes have their own functions and their own uses, right? And we need to manipulate their uses without creating a script for every single one of these and using a bunch of more complicated means of producing our results. So instead, we will get a reference to a node and use it within one script instead of jumping from script to script. So an easy way to get these references is you can click on a node, press Control, and drag it onto your script, and let go. And you get the reference right there. Okay, so we have references to the nodes, and the @onReady ensures that the nodes are basically introduced at the right time. Otherwise, the variable would not be would be null, as in it doesn't have a value, and that would mess up quite a bit of things. Okay, so I think I said that this video wouldn't introduce any hard concepts of scripting. I completely lied, but this, I'm almost 100% sure if you make it through this script, I'm telling you everything else that we go over will be maybe 10 times easier. Okay, so this function ready, what does it mean? So a useful feature in Godot is if you press Control, you highlight any inbuilt function, which this is an inbuilt function. You can left click on it and it brings you to the documentation. So as you can see, it's called when a node is ready. So it's basically when a node enters a scene tree. As you can imagine, this is a scene, as I went over in the beginning of the video, and everything else is, you can refer it to a scene tree as a whole. So once the nodes basically spawn in, or the node with the script spawns in, the function ready will be called. And you're gonna set our mouse to be basically hidden and locked in the center of our screen. So I control clicked on that, and yeah, this just sets the mouse mode. It's not really anything too complicated. Okay, so now we go into a little difficult part. As you can tell, this is where defining a variable comes into play, or a parameter. So we have a function, and this is an inbuilt function, of course. When you type it out, I'm sure, I don't think, yeah, it does not come with input event. You don't really need it, but if you want to build a good habit, I'd recommend you type that in. Anyways, so what this line is saying, or actually I should start with the function. So the function is basically, let's control click on this. It's called whenever you do something with your keyboard or mouse, essentially. So if this if statement in Godot 4, all you have to do to create an if statement is you type if, and then whatever you want, like the variable you're referring to, you type that in. So event, right? And then you can do equals 0, right? So if number equals 0, then you type a colon and you press enter, and it will automatically indent the next line, and you type whatever you want to happen after this is true. Okay, so what this line of code does is it says, it checks if we're moving our mouse. Pretty sure you can tell by that, the name. Anyways, the next couple lines are pretty hard to understand, but we're gonna rotate our character on the y-axis by the event relative times mouse sense. So mouse sense is a variable we defined. Obviously that's going to be our mouse sensitivity. And with the event.relative.x's, it's basically getting the coordinates of our mouse in 2D matters, of course. And that's all it's doing. But it's only getting the x coordinates. So if you could imagine like the screen as a huge graph, that's basically what it's doing. It's just getting the x coordinate of their mouse. And then we're rotating the y-axis by this, right? So you could see what the y-axis is. It's basically this, right? You can see it. So that's how we move our camera left and right. Now for up and down, it's going to be the exact same thing, except you're rotating it on the x-axis, which is this, and you're getting the y coordinates of the mouse. And of course, we do not want to rotate our camera 360 degrees. We don't want it to rotate it 720 degrees. So we're going to use a method called clamp. Alright, so we're going to clamp the rotation of our neck, right? We're going to make sure that it cannot go past a certain value. That's essentially what the clamp method does. And we could actually set it to 2 values. So the rotation, the next rotation on the x axis has to be between these 2 values. And the degrees to radians is just simplifying it's just converting degrees to radians, of course. Anyways, you can write this down quickly if you want. It's just, you'll see how it ties in later. Alright, so onto the physics process function. You'll notice that there is a parameter, just like this function. Wait, never mind, I lied. Oh, actually, never mind. Event. Notice that's also a parameter. And if you don't know what a parameter is, it's basically a value that is passed through a function. So you could think of this as a variable that's unique to this function. And the variable's value will be dependent on, I guess in this case, the what delta is. It's basically, let's see if it's okay. It's basically a combination of like your frames and the times between each frame. It's kind of a weird concept to describe, but the engine itself will pass in this value because this is an inbuilt function. Anyways, we're gonna get into the more complicated part here, which will have to do with velocity. So there's an inbuilt property, or yeah, let's just say property, that's called velocity, which is a part of the character body 30. And we're going to set velocity equal to getDirection.rotated vector3.up rotation.y times speed. Basically, what this does is it calls the function that we'll declare later, and it just sets what direction is up, basically, and it multiplies it by our speed, which is a variable we set. And feel free to like mess around with these variables, because as long as you don't change it too significantly, nothing should mess up. Okay, so this part right here is responsible for implementing gravity. And in this script, you notice that there's something called the y speed. This is essentially velocity.y. So I can click on velocity here, and velocity is basically, as you can see, it's the vector that is transformed into like a velocity. Okay, so you can see right here there's an if statement, and it basically says if the character is not on the floor, we're gonna add gravity onto y speed, which is the velocity dealt y. So essentially it's gonna push us down. And is on floor is an inbuilt function that, or method, sorry, that returns true if the character body 3D is on the floor. So if not is on floor, we'll check if it's not on the floor. And then if it is on the floor, sorry, then y speed will be set to 0. So then you won't be going into the ground, and jump number is going to be set to 0, and it'll make sense what exactly this does in a second. Anyways, we're gonna get one more, or there's gonna be two more inputs or events, right? They're basically the same thing. So you can do if input dot is action just pressed jump. You can type all that, but just as a reminder, there's a little step you have to go through before the code could work, and I think I forgot to mention this, but you go to project settings and you click input map. It should be right to the right of general, and all you gotta do is gotta fill out your keybinds essentially. So I wanna move forward. I want to be able to move forward. You type it in this box, press add, unmove backwards, unmove to the right, and I want to be able to move to the left. And you can see that we have a jump and sprint option, so let's add those two. And you can press enter to add these instead of pressing add. And then you're going to click these plus buttons. Let's say add event, right? Click them, and you click the button you'd like to assign, or click the key that you'd like to assign to this event. So for forward, I'm going to press W. You can press OK. And if you really want to, you can add a multiple keybinds for the same event. But I'm just going to fill this out to what I'd personally like. So WASD, and then space for jump, and I'm going to use shift for sprint. Alright, so that's done. You press close, control S to save, and once again, this is going to check if we press our jump keybind, and if jump number is less than the max jump amount. And then if that's true, we're going to call a jump, which is the function we put right here. Alright, so now that we have all the jump, like, I guess, features built in, so I'll go over exactly what it does. So you can see at the top, we declared two variables related to jump. Jump strength, or actually three, sorry. Jump strength, jump number, and max jump amount. What the jump amount does is it'll keep track of how many jumps you've used. Max jump amount will set the limit of jumps you can do at one go. So if you want to have 3 jumps, you would just set this to 3. And you could be able to jump up to 3 times before you have to touch the ground, right, which is what this does, and then it'll reset. Okay, so we're gonna have 1 jump before you touch the ground, and then you can jump again. And then we call it jump, right? And all we do for this is we set y speed equal to jump strength, and that's just, again, the velocity dot y. So nothing too complicated. You're just adding more to the y vector, right? And then we're gonna do something for speed, and I'll change something really quick. So we're gonna actually add another variable called speed, no, sprint speed, and that's gonna be set to 40, actually 20, and you're gonna come down here and just copy this line of code, or actually before you do that, let me change it. So if it's on the floor, then speed plus equals sprint speed, and then we're gonna copy this. Okay, that should be it. That's the only change we need. And if you're wondering what this plus equal means, it's just a simpler way to write what I'm about to write out. So it's just speed equals speed plus sprint speed. So you can see this is definitely an easier way to write this out, and it's a good habit to build, so I'd recommend using that. And I'll go over what this does. So if you press the sprint key, right, and you're on the floor, because you don't want to sprint in midair, that doesn't make sense. So if you're on the floor, you're gonna add sprint speed, which is the variable we just created, onto speed. And if you're not on the full floor, your speed is going to be 20, which is the default value. And if you're not pressing the sprint key, your speed is going to be 20, which is also the default value. Yeah, that's really all it is for sprinting. And next, the camera rotation. So this line is just there for extra effects almost, and all it's gonna do is it's gonna add almost a tween or an animation kind of when you move your camera up and down, or not up and down, when you start moving. So if you press W, right, your camera will tilt slightly forward. You press S, it'll tilt slightly backwards. This, I have to admit, is not that difficult to understand, but it would be if you don't really have any programming knowledge. But basically, you're setting the camera 30.rotation degrees.x, right, to this method, the result of this method. And what lerp does is it smooths out a value. I think it is 2, yeah, basically it's 2. So you can see it takes in a beginning value, and end value, and a weight value that will determine the smoothness. And it's really good for smoothing out camera movement. Otherwise it looks quite choppy. So again, the 0.1 is our weight. This is a variable we defined, and that's our 2, right? And this is our from. So it will be somewhere in the middle, but mainly on this side. Okay, so, and once again, I believe, yeah, so the neck is rotating on the x-axis when you move your mouse up and down, and then the rotation, this line of code is going to be added onto the camera 3D. So you can see there's a difference between them, and that's so we don't, cause too much of a tilt. Okay, and then velocity.y equals y speed. We're just setting, this y speed was originally a placeholder, so we're making the velocity.y equal to y speed, because once again, y speed was just a placeholder for velocity.y. And then we have to call move and slide. And move and slide is just an inbuilt method which you need to use if you want to move. So there are quite a bit of options. I did not mean to click that. There's some options for move and slide, but don't really need to change anything. Okay, so the last part of the code that we have is function get direction, and we're going to create a local variable. So this variable, it cannot be used in physics process, it cannot be used in jump, it can't be used in function ready, it can't be used in function input, it can only be used in function get direction. And once again, we're setting this variable to a vector3 value. Alright, so an example, I can make a variable called variable direction, right? And this is set to nothing. But if I felt like getting the x value of the property, I would not be able to. So that's the main purpose of setting the value data type. So you can see I have x, y, z, I have all of these options that I wouldn't normally have. Obviously you would, but they're not filled in, and this could be a useful tip or a useful feature. It's just good to have. Anyways, so we're gonna set the x coordinate of the vector3. Vector3 is just 3 coordinates. As you can see, the transform takes 3 coordinates. So it's in a 3D space, and you get the x axis. And what this does, these methods do, the get action strength, basically, it will check if you're pressing the assigned keybind, right? And if you are, it will turn a certain value. I think it is 1 if you are pressing the keybind, and I can check. Yeah, so it's 1 if you are pressing it. So if you press right and left, you obviously won't move anymore. If you only press right, you'll move to the right, because this will turn 1 and the left will be 0. So 1 minus 0 is 1. And if you do the opposite, you'll be moving to the left, right? Because -1, or 0 minus -1, or 0 minus 1, sorry, is a -1. And you can see here, this is positive, this is negative, and I guess I should flip my orientation. So again, this is positive, negative. You can see that's to the left, that's to the right. And then we're going to do the same thing for moving forward and backwards. And this is on the z-axis. So you can move that way or that way. And these 2 lines are again just camera settings, I guess. And yeah, I don't really like them, so that's why I set the values to like 0. But if you want to try them, go ahead. And the final line is return direction dot normalized. In this return, what this keyword does is it will basically pass in the value which is to the right of it. So as you see, velocity is equal to get direction, and when you call it get direction, it will basically, when the game runs, it will replace get direction whatever this value is. And normalized, you can see here, basically just converts it. And that should be all for our player to work. In the next video, hopefully in the next video, we'll go over how to create the maze, the actual maze, you know? So we'll go over more collisions, randomness, static bodies, area 3Ds, I think. But yeah, if you enjoyed this video, you want to see more tutorials like this, more guides, please like, subscribe, and let me know if you want to see, if you have any suggestions of any videos you'd like to see. Thanks for watching.